Okay, so in this particular circuit, we've got a lot going on. We have a total, if we wanted to look at KVL, we have 4 different loops we could look at. We have each, well, actually we have more than that. If, you can do any loop you want. So I could do this loop, I could do this loop, I could do this loop, I could do a loop around the entire thing, or I could do a loop around this bottom branch. So I typically don't do all that. You usually find what you need soon enough by doing a little bit of KVL and a little bit of KCL. But let's label some things on our circuit here. So we've got IB is already labeled for us going to the right. This bottom one, that's supposed to be IA. That's IA. So IB going to the left, IA going to the right. We have IG going down the middle. We know IA is 4 amps. We know IB is negative 2 amps. Let's see if do I want to define a reference node at this point? I don't. Let's define 2 currents right here. So I'm going to define one going to the right and one going to the left. So I'll have I1 and I2. So KCL tells me that, notice the way I happen to draw them, they're all going out. So that I1 plus I2 plus IG has to equal 0. And let's get I'm gonna call, if I make this ground, then this voltage right here would be VG, because that's how it's labeled right here. That voltage would be VG. Now I want to be really careful. Notice where I put ground. I put it right in the middle here, and I've got this 100-volt voltage source over here. I cannot label this node right here as 100 volts, because it's not, because that would mean it's 100 more. It's 100 more than what's on the other side, but the other side is not 0. It's not 0 because I made 0 here in the middle, and there's a resistor in between. So I can't do that. Now what I can do is I can right now find out the voltage at this bottom left node, because I know what IA is. So I know that the change in voltage across the 15 ohm resistor is, so delta V equals IR, and so delta V equals our current, which is 4 amps, times our resistance, which is 15 ohms. So our change in voltage is 60 volts. And this is going from left to right, so that tells me that, and I is positive, that tells me that my left-hand side has to be 60 volts higher than my right-hand side. My right-hand side, I made 0, this has to be 60. So if that's 60, then this voltage right here has to be 160. Let's see. So what else do we want to do here? We know that IB is negative 2 amps. So that means that, and then take a look here. You see how those are all in series? So I could say that this top branch is equivalent to, right here, so this top branch, since these three resistors are in series, that is equivalent to 130 ohm resistor. And so we have that this is 160 volts right here. And we know that it's negative 2 amps going through this one. So that means the change in voltage going across this resistor is negative, so delta V equals negative 2 times 30 equals negative 60. So we want to be careful about what that means in terms of how we actually label it. So the current is negative 2 amps. And so what we actually know is that if I could call this VA and this VB, that I would say that VA minus VB over 30 equals negative 2, or VA minus VB equals negative 60. I know that VB is 160, so VA minus 160 equals negative 60, or VA has to equal 100. So I have 100 over here. So my voltage right here is 100. Not right there, sorry, right here. Well, it's the same here. I just need to be careful about where I put it on this top circuit. So it's right here. It would be 100 volts right there. Alright, let's see if we have anything else that we can do here. Looks like I'm going to need I look at these two resistors right here, and I see that they're in series, so I'm going to replace them with a 20 ohm resistor. So I had 20 ohms there, 30 there. I had, this was 100 volts. I had this labeled at 160. I had, this is 5 ohm. This is a 30 ohm. This is, no, I took care of that one. Hold on just a second. You'll give me just a second. What? Sure, I'll do that. I'm teaching a class right now, but I'll zoom in with you later. Okay, no, it's not your phone. Okay, alright, bye. This we said was IG. We had that this was 100. This was ground. This is 15 ohms. Alright, I believe that I can get a current going through this 20 ohm resistor right now I don't have that labeled in my original drawing, but I may find it useful. So I can say that this current, I'll call it IC. So I can say that IC equals 100 minus 0 over 20, or IC equals 5 amps. So I have 5 amps here. I had, this was minus 2 amps if I recall. So now if I look at this node and I have 5 amps going down and I have negative 2 amps going up, that is equivalent to saying I have 2 amps going down. So can y'all tell me what the current needs to be in this branch right here? If I have 2 amps coming in here and 5 amps going out there, what would the current need to be in this 30 ohm resistor? So let's think about it like this. So I'm curious about the current, and I think I labeled it, I don't remember what I labeled it. I labeled it something. I labeled it I2. So I have I2 right here, and I had negative 2 going this way and 5 going this way. So if I just want to write a KCL equation for it, if I don't want to like kind of try to get all these pluses and minuses into my, figure out what they all are, I can just say current going in has to equal current going out. Current going in is I2, has to equal current going out is minus 2 plus 5, or I2 has to equal 3. So I have 3 amps right there. So I2 has to be 3 amps. Now I can do a KCL over at this node. Can I? No, I don't have enough yet. Okay. Let's do, if anybody has something they want to try, I'm happy to do what y'all want to do, or I'll just do it the way that I'm going to do it. So whatever y'all want to do next is fine. So I think I would take, I'm going to take a loop around the entire outside. So, going around the entire outside, I'm going into I have a OneNote that won't let me add any extra space. And it's just not going to do it. Oh, wait, there we go. Okay, so going into the 100 volt voltage source, I'm going into the negative side, so negative 100. And then, okay, so let's take a look at this top resistor here. I'm going in this direction to the right. The current I have labeled is going to the left. So that means that my the current I will have here will be the negative of the current I have labeled, which is negative 2. So it's minus negative 2 times 30 ohms. And then I come to this 20 ohm resistor. My current going in the same direction as my loop is 5 amps times 20 ohms. And then I get to this last one. I don't have this current labeled. I don't think I do. So I'll call that ID. So plus ID times 15, and that has to equal 0. So now I have a nice equation that only has one unknown in it. So that's negative 100 plus 60 plus 100 plus 15 ID equals 0, or 60 equals negative 15 ID, or ID equals negative 4 amps. Alright, so now I'm in a position to find IG. So let me look at this bottom node right here. So the bottom of this circuit right there, I have IG this way, I have ID this way, and I have 5 amps coming in. And so current coming in has to equal current going out. So current coming in is IG plus 5, has to equal current going out is ID. IG plus 5, and ID was negative 4. So IG has to equal 1 amp. So IG equals 1 amp. And that is not the right answer. Oh, I'm so sorry. Because if you subtract 5 from 4, you get negative 9. It's all about that addition. Yeah. So subtract 5 from negative 4 and you get negative 9. So luckily my mistake was only in this last step. So IG is negative 9 amps. What else are we supposed to find? The power dissipated in each resistor. I am not going to do that. That is too much to do. VG, we will find VG. So VG would be the voltage across this current source. So let's go back into a prettier picture, and now let's label the stuff that we know. And let's make a nicer picture for it. So we've got and we replaced this with an equivalent resistor. So we know we have this was 15 ohms, we had this was 20 ohms, we had this was 30 ohms, this is 5 ohms, this was 30 ohms, this was 100 volts, we had negative 2 amps in this direction, we had 5 amps in this direction, we had ID was negative 4, so we had negative 4 in this direction. IG was negative 9. Let's see, did we know anything else? We had that seems to be what I know. Alright. Oh, we did have this one. We had this one, that current had to be 3 amps right here. Okay, so and that this was, we made that ground, which made this 160 and made this 100. Oh, okay, well actually, so and I just drew a whole lot that I didn't need to do in order to find VG. So if this is VG, if VG is, and I have to be careful, VG in my original picture, let's look at what VG is in my original drawing. VG is the voltage across this current source. And that will be whatever voltage I have labeled here, because on the other side I made that ground. So using the voltages I have labeled, if this is 0, then whatever voltage I have here will be VG. And so this is going to be easy because I already found that this current was 3 amps. So I know that VG minus 100 over 30 equals 3 amps. So the current going from VG to 100, VG minus 100 over 30 is 3 amps, or VG minus 100 equals 90, or VG equals 190 volts, and that is, in fact, the right answer. 190 volts. And let's see, what else? Find the power, dissipate. No, and I said no, I'm not doing that. So, if you want to do that and then send me your answer, I will tell you if it is right. But that's, I don't, so to find the power dissipated in each resistor, what I would need to do is have the current through each resistor. I pretty much have that, but I would also have to have, well, it wouldn't be that bad since I have the current through each resistor, because I know normally I use power equals IV, but in this instance I wouldn't, because I don't want to find the voltage change across each resistor. So I also know that since V equals IR, power equals I squared R. And since I already have most of the I's, I think the only I don't have is I1, but you could get that. It wouldn't be that bad to find them, but I am not going to find them, especially because I'm almost out of time. So are there any questions that y'all have before we wrap this up?
I have a question.
Sure.
For like on our homework, we have one where like there's no wire in between, but it says to calculate like the voltage in between it. Do you know is it
Yeah.
like how we should approach that?
Sure. Can you tell me which problem it was?
It's the very last problem on the homework, number 4.
All right. Let me see if I can get to it. Um, did it have a number from the book?
Yeah, it's 2.20.
It'll just be easier for me if I can get it off. If I can look at the, I can't do the actual homework problem for you, but I can
Yeah.
look at it and see if now it's causing me a problem that I can't use my mouse. Let's see, do I have the book?
Because I think it's
Wait,
gonna
I've got the
be
book right here. Hold on, I got the book. $220.
I think it's gonna be
Okay.
page
Yep,
104.
I see it. I see it. Okay, so hold on. Let me come back and share my screen again.
But I think is it KCL and KVL too? But I just got confused. Like, what would you do if there's no wire in between?
Yeah. Okay. So it looks like this. And you are supposed to find V. This is labeled plus, this is labeled minus. So VAB. Okay, so the way I would go about doing this is I'm not. I'll get you started. And I actually can't do it because I closed the book and I don't have the numbers, so that's good. So I can't do your actual
Okay.
problem. But
Yeah.
what this means would be if I pick a reference node and I have these voltages labeled relative to that reference node, then it would be the voltage at A minus the voltage at B. So I would label this bottom, the branch, as the reference node and have that be 0. So that means that VB is 0. And then I can know that this voltage is whatever this voltage source is. So let's say that this voltage source is 10. Since the bottom is 0, the top has to be 10 more than that. And now, if I can find the current going through this resistor, then I know what the voltage is on this side relative to the 10 over here. So let's just say that this resistor is a 5 ohm resistor, and I find that the current going through this is 1 amp, going in this direction. Then I know V equals IR, that this would be 1 times 5 is 5 volts. I know there's a drop of 5 volts across this resistor, so I know that this side, A, has to be 5 volts less than this side, which was 10. So I could label that as 5 volts. And then I can say that VAB is 5 minus 0, which is 5. Does that make sense?
Could you share your screen, please?
Oh! Yeah, I think that would probably be helpful, huh? Yeah,
I
that'd
was
be very
following
helpful.
it along for a little bit, but then could I have
Yeah,
it in front of me?
that's funny. Okay, so hold on. Yeah, I will share my screen. No, you have to do it all in your head. Okay, let me go back. All right. Okay, so yeah, I did. This is lovely for me. Okay, so I said that I labeled. So I have a similar circuit to the one from your homework. So it's not the same. So but it's very similar. So let me tell you how I'm gonna do this.
You'll set B as ground, so have
Uh-huh.
0.
I did. So I'll make this ground, and I decided that I wanted this voltage source to be 10 volts and this resistor to be 5 ohms. I don't know what you have in yours, but so the way this circuit is drawn, then I have that this voltage right here would be 10 volts relative to ground. Now, let's say that this voltage right here is 6. So now I'm doing something different than I did a minute ago, but now I've got that this is 6 volts. Well, there's lots of different ways I could go from here. Let's say that this resistor is 1 ohm right there. Then I know there was not another there was not a branch in here, right? There was not something between A and B. That was the point. Okay, so I can say that the current going across this branch in the middle, that's I. I can say that I equals 10 minus 6 over 6, because my resistance, my equivalent resistance in the middle there is 6. So that's 4 over 6, which is 2/3. So that would be my current going through this branch across the middle. And then I could use that current in this 5 ohm resistor to say that the voltage change across this resistor is 5 times 2/3, or 10/3, or 3.33, which means that I'm going to be 3.33 less on the right-hand side than on the left-hand side, or 6.7, I think, with my made-up numbers. So relative to ground, now VA is 6.7, so then that would tell me that VAB is 6.7. So that's just one way to do it. I mean, you could find, I mean, I found the current through this middle branch. You could also find the current through the top resistor if you wanted to. So there's lots of different ways that you could do it.
Could you use KCL and KVL on this?
Sure.
Hmm.
And by the way, when the way I'm doing things really is kind of KVL and KCL. I just don't call it that. But let's do it that way. So let's say that I have a loop right here. Okay, so I have a loop through that bottom. Then I've got going across the way I have this drawn. It would be minus 10 plus 5i plus 1i plus 6 equals 0. And then that would give me 6i equals 4, or I equals 4/6 or 2/3. So that gets me that my current through this middle branch is 2/3 amps, which is what I got before. And then I would still have to use Ohm's law. At some point you have to use Ohm's law to get the voltage change across either this resistor or this resistor. It does not matter which one you do. But you would use Ohm's law to get your voltage change across that, and then you can get your voltage in the middle relative to the voltage on either side.
But for the they're going to be the same current going through the first resistor and the second one.
Yes, and that is a very good point to make. So let's take a look at that and see why. Is this the correct current, the correct circuit?
Yeah. Yeah.
Okay. And nothing in here. So what you need to see here is that these two resistors are in series. So anything in series, same current, because it doesn't have anywhere else to go. So whatever current I have going through this first resistor, it doesn't have anywhere else it can go. It has to go through the second resistor. So you have the same current through both of them. What you don't have is the same voltage across both of them, because as you go through one of them, the voltage drops. As you go through the other one, the voltage drops. So things in series have the same current. On the other hand, things in parallel have the same voltage. So if you have the current through one, it's the same as the current through the other.
Okay, yeah, that's where I think I messed up because I was doing it, but I had like two different, I had I1 and I2, and I didn't know how to find
Uh-huh.
the the
Yeah.
current through there.
Yeah, I mean, you certainly can label this I1 and label it I2 over here, but at some point along the way, you're going to need to end up saying, oh, wait a minute, I1 equals I2. And then, so like I could say, it's like perfectly reasonable to say, if I have VA here, then I can say, and this voltage is whatever it is. I can say that I2 equals VA minus 6 over whatever this resistor is, R1. And if I have I1 going this direction, and maybe this voltage is 10, I can say that I1 equals 10 minus VA over this resistance, which is R2. Nothing wrong with either of those two things. But then I would say, to finish this problem, I'll say I1 has to equal I2. So 10 minus VA over R2 has to equal VA minus 6 over R1. And then you could solve for VA from there.
Okay,
Okay?
thank you.
You're welcome. So, I mean, I think that kind of one of the things I've shown, and I have to get going because I'm supposed to be somewhere else at 7, that there are always lots of ways to work any problem.
Okay, all right, thank you.
You are welcome. All right, so I do have to go, but if you have any other questions, do feel free to email me. And y'all have a good evening.
Thank you.
Yeah, you
Bye.
too.